Today I'm going to do a couple integrals that involve trig substitution. Many times integrals with trig substitution have radicals in them where you either have a variable minus a constant. In this case, under the radical you have a constant minus a variable, or they may be a plus, in which case the hypotenuse would be the entire radical. When there's a minus here, you want to put the square root of your positive as your hypotenuse. So I'm going to make the hypotenuse 3. I'm going to put x as this leg, and hopefully the bottom leg is going to be the radical that's in our integrand. You need to make sure that Pythagorean theorem works on this triangle, which it should. Leg squared plus leg squared equals hypotenuse squared. Now I'm going to find the value of x. X is the opposite, and I wanted to use it with a constant. So opposite over hypotenuse. Opposite over hypotenuse is sine. Sine of theta is opposite over hypotenuse. So 3 sine theta will equal x. This integral does not contain an x. Many do. They all have a dx, so I need to find dx. To go from x to dx, you take the derivative. Keeping your constant out front, the derivative of sine is cosine of the same angle times the derivative of the angle. So when I do this integral, I'm going to replace the dx with 3 cosine theta d theta. The other thing I need to substitute is this square root. The square root is the adjacent to this angle. Again, you want to use it with a constant. So adjacent over hypotenuse is cosine. Cosine of the angle is the adjacent, square root of 9 minus x squared, over the hypotenuse, 3. If you multiply both sides by 3, 3 cosine theta is going to equal this square root. So the square root will be replaced with 3 cosine theta. At this point, 3 times 3 is 9. I'm going to factor it out front. Cosine times cosine gives me a cosine squared. There's an identity for cosine squared where it becomes 1 plus cosine, in this case 2 theta over 2. Factoring out the 1/2 makes this a 9/2. I usually keep the 9/2 out front of everything, and I'm going to integrate these separately. 1 d theta plus the integral of cosine 2 theta d theta. Again, the 9/2 stays out front. The integral of 1 d theta is theta. I'm going to attempt to integrate this by turning it into cosine of u du. If u is 2 theta, its derivative du is 2 d theta. So to create this, I need to multiply by a constant of 2 on the inside here. That becomes a du, and its reciprocal on the outside. And the integral of cosine, or what do you take the derivative to get cosine, is sine. So it would be sine of u, or in this case sine of 2 theta. So I'll keep my 9/2 out front. Theta. I need to solve for theta. I know that sine of theta is x over 3. To get rid of the sine, I could take the arc sine. So if I do the arc sine of both sides, theta will equal the arc sine of x over 3. So this will equal the arc sine of x over 3. Remember, if the integral starts with x's, you need to end with x's. Plus, now, I don't like mixing x's and thetas, so I'm going to do this up here on the side. there is an identity that says sine of 2u is equal to 2 sine u cosine u. So this could be 1/2 2 sine theta cosine theta. So if I was to replace this here, 2 and sine theta I know is x over 3, and cosine of theta I have as the square root of 9 minus x squared, also over 3. So I replace the cosine and I replace the sine with x over 3. The 2 and the 1/2 will cancel, leaving me with 9/2 quantity arc sine of x over 3 plus x square root 9 minus x squared all over 9 plus c, because this is an indefinite integral. Now there are various ways that this could be left, but this is the way I'm going to leave it, and I believe this is correct. The next one I'm going to do involves a constant minus a variable. I hope this one helps. Good luck.